as you see when you practice worksheet 15a, it's very laborious to determine the elastic curve function uh, and the deflection with application with the relationship between the moment and curvature. And the engineering try to use the tables to have that, because in the real life you have multiple load on the beam. How can we use every load and then we do with the integral and derivative that we did in worksheet 15a? It will be take for a long time. So today now we move on to a method that we call superposition, and we use the table to determine the beam deflection, and it also be able to solve the indeterminate beams. So let's first define what is the principle of the superposition here. Principle of superposition. So just like a Superman, is that right? Not really. So superposition, by definition, the superposition definition is the process of determining loads, stresses, deformation, like deformation, deflection, angular distortion, all of that. So deformation, by considering several loads, stresses, and deformation one at a time. So by considering several loads, stresses, deformation, etc., or deformation one at a time, and then add them together, and then adding together. So what does that mean? If we have multiple loads, if we want to solve for the load, we consider each load one at a time, and at the end we can be able to add them together if we find out the load. If you want to find out the stress, also you consider the load or stresses or deformation one at a time, and then with the results of the stresses for each of the load, then you can add them. What are the limitations for this method? Limitation. What is the limitation for this? The first limitation is the geometry not significant outer, so with very small angles. That for sure, because otherwise real life, of course, nothing that slope or deflection a lot, that structure may not be functional. Geometry not significant onto, not significantly onto. And then the second limitation to apply the superposition is have to be linear elastic. Linear elastic. So that is the two limitation before we can apply the superposition. And like I say, engineer try to use the table and that we have in appendix D, we have elastic beam table. Elastic beam table in appendix B, appendix D. I will show that to you in a minute. Just let here write elastic beam table. What is that about? Let's go back to the appendix D. Beam deflection and slope. As you can see, we have 5 columns here. The first either show the support of the beam, the load applied, etc. And then the next column show the elastic curve, how it behaves here, where Y max, we see the maximum deflection on the beam, and what is the associated equation for the maximum deflection as defined in the second column, and slope at end of the beam, what is that for that scenarios. And we have the elastic curve function equation y-axis for each of the scenarios. So as you can see, we did the problem with C 15a, and you can be able to find out the elastic curve function with multiple integral, and then end condition to determine that equation. But at the end, basically the equation to find out is either similar to the figure 7 as you can see there for the worksheet 15a, and with our integral take a long time to solve, and at the end if you go back to 15a you have that similar equation in here. So in this case, as you can see, for each of the support condition, load, they give us the equation for elastic curve, slope, etc. So that if we just use table. But in order to use table, I just want to make a note in here, because to use the elastic beam table that I just showed you in appendix D, let's write down here. D. So what do you have? To use this beam, we have to say beam must look exactly like the picture. Must look, very important, exactly like the picture, which is in the first column of appendix D, as I show you back here. So the first column here, the beam that the problem solved would have to look exactly the same of the picture here, including the support condition, including the load applied, the geometry, all of that. So that what we mean exactly the same. So what here, let me elaborate three things that need to be exact. The first is same end condition. Same end condition. Number 2, have to be same load. If it concentrated load, have to be concentrated load. Distributed load, couple, same load. And then same point of interest. Same point of interest. Because different point have different deflection and different slope, right? Same point of interest. So those are the conditions to apply the elastic beam table in Appendix D. And for the next 3 problems, worksheet 15B, C, D, to solve the deflection or to determine the reaction for indeterminate beam, we must to use Appendix D with condition that I just show in here. So and apply the process called superposition to solve.